how air columns vibrate inside a closed pipe, where F1 is called fundamental frequency of vibrations. For an open pipe, it is 1:2:3. The distance between a node and an antinode is lambda by 4. Therefore, during the vibrations of air column in a closed pipe, hello students, this is SD Sir from the Temple of Excellence, Vidyashram Pre-University, Mysore. In my previous session on waves, we studied a very unique and interesting kind of wave called standing waves or stationary waves. We told these waves are formed when two progressive waves of the same amplitude, wavelength and velocity travel in a medium in opposite directions. We told there are certain regions on this wave where the particles are at rest and called them as nodes. Certain regions where the particles vibrate with maximum amplitudes, antinodes. And we told energy is not carried across any section of these waves. In my today's discussion, we will discuss a very important concept, always asked as a 5 marker, modes of air column, vibrations of air column inside a closed pipe and an open pipe. Therefore, my first discussion here is to discuss the modes of vibrations of air column in a closed pipe. Exclusively 5-mark question. Modes of vibrations of air column in a closed pipe. How air columns vibrate inside a closed pipe. Therefore, my first understanding here is what is a closed pipe. In closed pipe andre, if I need to understand how air column vibrates inside a closed pipe, I should know what is a closed pipe. So we say a pipe which is closed at one end and opened at the other end is called as a closed pipe. Exactly something like this. So it is a pipe which is closed at one end and opened at the other end. So what is a closed pipe? Any pipe which is closed at one end and opened at the other end is a closed pipe. So these are the typical diagrams showing vibrations of air columns inside a closed pipe. Now, we say, let L be the length of the closed pipe. I assume capital L is the length of the closed pipe and V, velocity of sound in air. A closed pipe ittalva. We saw the closed pipe here. So L is the length of the closed pipe and V is the velocity of sound in air. If you typically observe the vibrations of air column in a closed pipe, wherever there is a closed end, we have the formation of nodes. And wherever there is open ends, there is formation of antinodes. Observe Madi. Whenever air column vibrates inside a closed pipe, ಒಂದು closed pipe ಒಳಗೆ air column vibrate ಆದರೆ always nodes are formed at the closed ends and antinodes are formed at the open ends. So very clearly I say, such that the nodes are formed at the closed ends and antinodes are formed in the open end. Now, in the first mode of vibration, ಇದನ್ನೇ first mode of vibration ಅಂತ ಕರಿತೀವಿ, which is also called fundamental mode. Fundamental mode of vibration, first mode of vibration. Again, as we see, a node is formed at the closed end and an antinode is formed at the open end. As we see here in the first mode, the so-called fundamental mode, again, the node is formed at the closed end and antinode is formed at the open end. Therefore, the entire length of the pipe comprises of half a segment. So loop ant karidvi, stationary waves. So here half a loop is present in the fundamental mode of vibration, something like this. Therefore, now it is important. What is the length of the air column now? How did I get lambda 1/4? If you go back to yesterday's discussion, where I gave you the characteristics or features of stationary waves, distance between a node and an antinode is always lambda/4. Whereas distance between two successive nodes is lambda by 2. Nenpitkobeku. The distance between a node and an antinode is lambda by 4, whereas distance between two nodes is lambda by 2. Illi closed endal node ide, open endal antinode ide. So the distance between them is lambda by 4. Therefore, the length of the air column is lambda 1 by 4, or lambda 1 is equal to 4L. Now, how do I relate frequency, velocity, and wavelength? Always know V is F lambda. V is wave velocity, F is frequency, lambda is wavelength. So V is F lambda. So F1 is V by lambda 1. Fundamental frequency lambda 1. Substitute for lambda 1. V by 4L. So this is the fundamental frequency of a closed pipe. Problem solve ಮಾಡಬೇಕಾದ್ರೆ ಯಾವಾಗಲೂ ಬೇಕಾಗುತ್ತೆ. Entrance ಅಲ್ಲಿ very important. F1 is V divided by 4L, where F1 is called fundamental frequency of vibrations. Now in the second mode of vibration, the length L of the pipe comprises of 1.5 segments. You'll beautiful analyze madidar nodi. This is the second mode of vibration. Again, a node is formed at the closed end. Antinode is formed at the open end. Here there is a complete loop. One complete loop is there. Here, half of the loop. So in the second mode of vibration, the length of the pipe comprises of 1.5 segments. Therefore, now if F2 is the frequency, lambda 2 is the wavelength, what is L? Yes, node to node, lambda by 2, half. If you can see, you will have node to node. Okay? So node to node, it is half, 1 by 4. So it has to be 3 by 4 lambda 2. Or lambda 2 equals 4L by 3. Calculating lambda 2, it is 4L divided by 3. So similarly, again, V is F lambda, or F is V by lambda. In this case, frequency is F2, wavelength is lambda 2. So F2 is V divided by, this is 4L divided by 3. Lambda 2 is 4L divided by 3. 3 goes to the numerator. So F2 is 3V by 4L. So observe here, what is V by 4L? Fundamental frequency. So F2 is 3 times F1. The frequency of the second mode is 3 times F1, which is the fundamental frequency. And we say this is the third harmonic. What is harmonic? It is the integers of fundamental frequency. All frequencies which are integers of fundamental frequency, they are called harmonics. So F2 is 3 times F1. In the next mode of vibration, third mode of vibration, the length of the pipe comprises of 2.5 segments. So now L becomes 5 by 4 lambda 3. 2.5. Half plus 1 by 4. So 5 by 4 lambda 3. Or again, lambda 3 equals 4L divided by 5. So F3 is V by lambda 3. So F3 is V divided by lambda 3 is 4L by 5. Again 5V by 4L is F3. Again, what is V by 4L? Frequency of the fundamental mode. So if you observe, we have F1 is to F2 is to F3 is 1 is to 3 is to 5, which clearly indicates during the vibrations of air column in a closed pipe, only odd harmonics are present. You're not getting the even harmonics here. F1 was V by 4L. F2, 3V by 4L. F3, 5 times F1. So only odd harmonics are present here. Therefore, during the vibrations of air column in a closed pipe, only odd harmonics are present. Now this is an assignment for you. Quickly I'll figure up. Let me see how many of you cope up with this. Modes of vibrations of air column in an open pipe. So as we compared there, closed pipe andre, one end was closed, the other end was open. Naturally, what is an open pipe? Both the ends of the pipe will be open. So this symbolizes how air columns vibrate inside an open pipe. So in the first or the fundamental mode, you clearly see, yes, antinodes are formed at the open end. Node is formed in between. So node to antinode, 1 by 4. Node to antinode, 1 by 4. So what is the entire length here? L1 by 2. So lambda 1 is 2L. So if you observe, antinode to node, 1 by 4. Node to antinode, 1 by 4. So 1 by 4 plus 1 by 4, half. So L is lambda 1 by 2. Lambda 1 is 2L. Again, V is F1 lambda 1. F1 is V by lambda 1. So this is the fundamental frequency of vibrations of air column in an open pipe. In the second mode of vibration, if you observe, there are two segments. Nodi, this is one complete segment, partial segment. Here partial. So 1 plus 0.5 plus 0.5. Two complete segments. Two complete means length is lambda 2. Again V, F2 lambda 2 or F2 is V2 by lambda 2. How much is lambda 2? L. But what we have done in order to express it in terms of fundamental mode, multiply and divide by 2 such that this is V by 2L. So this is 2 times F1. Now in the third mode, there are 3 segments. So L is 3 by 2 lambda 3 or lambda 3 is 2L by 3. Again F3 is V by lambda 3. Substituting, we get F3 is 3 times F1. So if you observe here, we have all harmonics present. For an open pipe, it is 1:2:3. So in the vibrations of air column in an open pipe, all harmonics are present. Closed pipe, it is only odd harmonics. Next, we have a very beautiful topic called Doppler effect. Since it is waived off for your examination, I don't discuss with that. And this ends the chapter waves. Next, I start with system of particles. Revise, practice these derivations. Have a nice time. Thank you.